So during last lecture, we completed the part of chapter 5, that is manufacturing, lab and curing. During last lecture, we have seen that how composite materials are manufactured, which are various techniques to manufacture the composite materials when these are in the form of polymer matrix composite or fiber reinforced plastics, and when these are particulate type metal matrix composites. So basically, as far as concerned with this subject, from first chapter we have studied the various types of composite, and we have classified that composite based on the type of matrix, type of reinforcement, and again with the help of that different types, the manufacturing methods also different. So with reference to this chapter number 5, manufacturing, layup and curing, we have seen the open and closed mold processings. What is meant by open mold process? That we have seen how closed mold processes are there, that we have seen. In case of open mold process, we have seen the hand layup technique, then spray deposition technique, then bag molding, vacuum bag molding technique, filament winding technique, pultrusions, pulp forming, thermoforming, injection molding. So these various techniques we have seen for manufacturing the composite material. Is it okay? This is very simple part, and with the help of these simple figures also we can describe these things. Is it okay? So this particular part that is completed. So from start of this particular subject, theory and analysis of composite material, the first chapter, introduction of composite materials, that we have finished. Then second, macro mechanical behavior of lamina, that part we have completed. And then manufacturing and layup of this composite material, that part we have completed. As far as concerned with micro mechanical behavior of lamina, we have completed the introduction, strength of material approach or mechanics of material approach, then elasticity approach to the stiffness, evaluation of four elastic constants, rule of mixture. So that part we have seen. And then we are coming to the last part of this chapter number 3, and that last part is related with the failure theories. Is it okay? So strength, biaxial strength theories, maximum stress theory, maximum strain theory, Psi-Hill theory, Psi-Wu tensor theory. So this part that we are going to finish with this lecture, so that we will be able to complete these 4 chapters. So chapter number 1, 2, 3, that contains section first. So section first will get completed with this chapter, and in section second we have already completed this chapter, manufacturing, layup and curing. Is it okay? So with the finish of this particular part of failure theories, we will switch over to the macro mechanical behavior of laminate. Is it okay? So that part will be remaining only. So as far as concerned with these different failure theories, we should take the reference of this cow, and with this we will go ahead the strength failure theories in case of composite materials, that we will see first of all. So we will have to go fundamentally from our strength of material, because in analysis of mechanical element, or in case of this we can see it as this mechanics of material, in case of machine design first, machine design second, we have studied this different failure theories. We started with the concepts of the stress, strain, failures in strength of material, but in machine design first and machine design second, we have studied the different failure theories. As far as with this first machine design first, we have studied the failure theories, and its application in machine design second was studied. Same thing we are going to carry out with this particular part of the study. So strength failure theories of an angle lamina of the composite material. So in order to design, or in order to successful design of any structure, it required the efficient and safe use of materials. Is it okay? So we know that the importance of design, why this design is important, the fundamental we know, because if we are interested to design safe structures or efficient structures with available materials, then we should understand first of all what are the properties of the material. Then we should understand what are the requirement of this particular structure, and then what dimensions of the materials can be used efficiently, safely, that is studied. And for that purpose, that theories of failure are needed. Is it okay? So that theories are needed to develop a to compare the state of stress in the material and failure criteria. Is it okay? We are comparing these two things. What will be the stress and what will be the failure? What is the maximum failure criteria of that particular material, and how much stress will get generated due to application of that particular force in that situation, in that particular structure when this particular material is used. Is it okay? And that's why these theories of failure that are very important to study in order to analyze the efficiency or safety of that particular part, structure, element, component, etc. Is it okay? So, failure theories are only stated and their applications is validation are validated with the help of experiments also. Means we are not only studying, we are not only analyzing this with the help of what we can say the theoretical concept, but by experimental method also we are going to validate this. Is it okay? And once again, this validated reports of the experiments and this theoretical part that we are comparing, and then we are coming to the particular um, results. Is it okay? So for that purpose, different optimization tools, techniques that we can use, apply, we can develop some mathematical models, and these particular mathematical models for that particular composite materials can be used by considering the percentage difference between experimental results and theoretical results. Is it okay? So this is the way of working with the composite materials. In case of laminate, the strength is related to the strength of an individual lamina. Is it okay? We know the difference between laminate and lamina now. Single lamina and number of such laminas will come together to form the laminates. For single, we are considering lamina, and number of such laminas we are considering to be laminate. Is it okay? So this allows for simple and economical method for finding the strength of laminate. So various theories have been developed for studying the failure of angle lamina. The theories are generally based on the normal and shear strengths of unidirectional lamina. Is it okay? Whatever the part of the study which we have carried from your second year onwards, whenever you first of all studied the mechanics of material subject, at that time our assumption was material is isotropic material. Even in last semester also we studied one subject, solid mechanics, and in this subject in solid mechanics also our assumption was that the material is isotropic. Is it okay? An isotropic material such as steel generally has two strength parameters, normal strength and shear strength. In some cases, such a cases, whenever we are considering the normal strength and shear strength, we know that shear strength is considered to be the maximum range to be half of that normal strength. If that particular material fails for 140 Newton per mm square, then definitely half of that at 70 Newton per mm square, this material will get fail if shear stress is applied. Is it okay? So the failure of shear stresses will happen with the half value of the normal stresses. So that is our conclusion from our previous study, which we have carried in machine design first and machine design second. So in some cases, concrete or grey cast iron normal strengths are difficult in the tension is different in tension and compression. In general, most of the cases it is assumed that in compression and in tension, in both the cases, the strengths are same. Means whatever the strength in tensile nature, same is in the compression also. Is it okay? But for some materials, it is exceptional. If we take the example of concrete, in case of concrete, its compression strength is large, but in its uh, tensile strength is less. Similarly, in case of grey cast iron also, there is difference in tension and compression. Is it okay? A simple failure theory for an isotropic material is based on findings the principal normal stresses and the maximum shear stresses. Is it okay? So principal normal stresses and the maximum shear stresses, these maximum stresses if greater than any corresponding ultimate strengths, that indicates the failure. Is it okay? Whenever we are calculating the maximum stresses, and if that maximum stresses are greater than the ultimate strength of that particular material, then definitely failure is going to happen. So values coming of the maximum stresses, that should be within the margin, within the safety, that should be less than ultimate tensile strength in case of brittle material, and less than yield stress in case of uh, ductile material. Is it okay? So that is generally which we can consider as the safe limit for carrying or giving the load. Is it okay? So by that point of view, this study of failure theories is very, very important. Is it okay? Now let us take one simple example and let go ahead, so that we will come to know that how this particular theories of failure works. Here one example is given, that a cylindrical rod is given. This cylindrical rod, which is made from gray cast iron, and when it is subjected to uniform uniaxial tensile load, is it okay? We know what is meant by uniaxial, biaxial, and triaxial. At the start of this subject, initially we have studied this particular part, or in case of the solid mechanics also, we have studied what is meant by these things, that is what is uniaxial case, what is biaxial case, what is triaxial case, that part we have already studied. When force is acting in one direction only, then we are considering it as uniaxial. Is it okay? So one cylindrical rod is present, and it is made from the gray cast iron. Is it okay? The material used for this cylindrical rod is gray cast iron, and it is subjected to uniaxial tensile load. Is it okay? So when this load P is acting on the material, and if the material is the gray cast iron, the specific values of this particular materials are provided as a part of an example. Is it okay? It is given that the cylindrical rod is made from the gray cast iron material, and it is subjected to uniaxial tensile load P is the maximum load which is given here. The additional values which I have provided here, inside that the cross sectional area of the rod is given to be a 2-inch square. Is it okay? Normally we use mm, but this particular part we can understand that there is a relationship between mm and inch. 25.4 mm is 1 inch. So here near about 50 mm square, that will be the cross sectional area of this rod. Similarly, ultimate tensile strength is provided to be 25. Then ultimate compressive strength is given by 95 ksi. Then ultimate shear strength is given as 35 ksi. Modulus of elasticity is given as a 10 EMSI. So these units that can be converted inch into mm square and ksi into Newton per mm square. So that already we know, but we should understand how these type of examples are solved. We should not go to the dimensional part or units parts, but we should go by the process. Is it okay? Which type of process are used in order to analyze the failure mechanism or failure type of this particular material. So this is one simple example to understand the case. And the simple example states that the uniaxial tensile load of P is applied on the cylindrical rod made from the gray cast iron, whose cross sectional area is 2-inch square, whose ultimate tensile strength is provided, compressive strength is provided. Both strengths are different. Compressive strength is larger as compared to tensile strength because material is gray cast iron. As we know that in case of gray cast iron, always compressive strength is larger as compared to tensile strength, which is happening here, and shear strength is also generally is considered to be half of that compressive shear strength, and near about it is considered to be 35. And with this, modulus of elasticity is also provided to us, and it has been asked to find the maximum load P that can be applied using maximum stress failure theory. We have heard this name maximum failure stress theory number of times. We know this maximum strain theory is also there. Maximum stress theory, maximum strain theory, maximum shear deformation theory, maximum distortion energy theory, strain energy theory. This kind of some of the theories we have already studied in our machine design first, which works on the principle of that particular terms which are used in that theories. Maximum stress theory, which works on the maximum value of the stresses. Maximum strain theory, which works on the maximum values of strains. Is it okay? So these theories, maximum stress theory, maximum strain theories, that we can study. Now in this case, the Mohr circle, that is also used. So Mohr circles analysis, that is also carried here. We are familiar that whenever we started this analysis of mechanical element at the first time, we have identified this Mohr circle theory, and with the help of this Mohr circle, 1 minute. Okay. So, so we know that this particular example with this Mohr circle analysis that can be used means here stress is given to be P by 2. Is it okay? And as we are using the Mohr circle analysis, all of we know that whenever the concept of shear stress we are using, so for that shear, that is always half of that. Whenever we are drawing with this Mohr circle by taking particular radius into the compass, then that radius and this diameter is the difference between that two stresses. Is it okay? And radius with the help of which we are drawing this circle, so that represents the shear component. Is it okay? So here P by 2 is less than 25 into 10 raised to 3, or P in this particular example which we have provided, the ultimate tensile strength is 25 and ultimate compressive strength is given to be 95. So lesser the value that we will prefer, because it may fail for tensile case, and in that case P by 2 is less than 25 into 10 raised to 3. That thing we will refer here, because if we are using the particular case of normal stress, then P by 2, and if we are considering the case of shear stress, then we will have to use the P by 4. Is it okay? So with these things we have to go ahead. So for normal stresses, if it is P by 2, then that is less than 25 into 10 raised to 3. And as because in the example itself it is given that for tensile strength it is 25, but for compressive strength it is 95. The lesser the value in between compression and tensile is tensile, and that is 25, and second is the ultimate shear. Is it okay? And for shear that value is 35. So when we are taking the reference of the shear, we will have to use P by 4. And when we are using the concept of tensile or compressive, lesser the value in between tensile and compressive and divided by 2, that will be the reference value. Is it okay? So with this, P by 2 is less than 25 into 10 raised to 3, and second one P by 4 is less than 35 into 10 raised to 3. That two references we are going to take now. Is it okay? The first reference P by 2 with reference to normal stress, and P by 4 the second reference with reference to shear stress. Is it okay? So when we compare here, we will get that with normal stress we are getting that P is less than 50,000. So here unit used is pound. We can convert pound into Newton. So with this the usual practice which we know. So process we should understand, because SI unit normally we use, but in this example it is used the different units. But here we can find the value that P is less than 50,000 pound when normal stress criteria is used. And when shear stress criteria is used, this value is coming P is less than 140,000 pound. Is it okay? So in first case P is 50,000. These two things with the comparison, what we are getting, with this comparison, we will get that here the maximum load in first case, whenever normal stress is taken as a reference, it is 50,000. But when shear stress concept is taken, it is 140,000. And comparing these two things, we get that the value 50,000, this should not be crossed because it is the safe limit. Is it okay? 50,000 is considered to be a safe limit and it should not cross beyond that, because in case of always this kind of analysis, always lesser value is preferred because it is considered to be a safe value. Is it okay? And that's why 140,000 and 50,000, out of which 50,000 is considered to be a maximum load that can be safely passed with the help of this grey cast iron rod if that is applied. Is it okay? It may be the case that compressive load it can take more than that, but the safe limit of the load which can be applied on this grey cast iron besides its compressive or tensile nature is 50,000, and that's why this value is considered here. So with that way, whenever the examples are solved, we are considering this as the concept of maximum stress theory. Is it okay? So here these values of this different ultimate longitudinal strength, ultimate longitudinal compressive strength, ultimate transverse tensile strength, ultimate transverse compressive strength, ultimate in-plane shear strength. So that notations how these are used, that is given. So tensile compressive on one direction, tensile compressive on another direction, so direction 2, and ultimate shear plane. So that is given here. So with this second part, that is maximum shear failure theory, that we will learn for tomorrow's lecture. So for today, I will stop here. Anybody, any doubt? Any doubt?